on us, they might tell you that why do we call it modern math? But it all started with how do we count and how easily we can count even those things that we cannot see. So let me just give you an example. If I have this five dots, not five, these dots. So how do you count? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If I'll say what is the number of dots now? What is the number of dots now? कोई भी बोलो कितने?
15.
And how did you count that? You did not count actually. You just saw that there are three pairs of five, no? Or three set of fives. किसने 15 बोला था बताओ?
मैंने सर यशमिता.
So did you count that or you just checked that there are three sets of five? No?
3 sets of 5 देखिए.
Exactly. And you said that there are 5 into 3, or somebody could have thought it like there are 5 sets of 3. So he would have called it 3 into 5. So these multiplications are, or these multiplication is interchangeable. Like if there is a definition for 5 into 3, then there is a definition of 3 into 5 also. So the 5 for 5 is to 3, you tell it that there are 3 sets of 5, and for 3 into 5 you call it there are 5 sets of 3. So, and this we will call theory of multiplication. Now let me ask you another question. There is a town A, there is a town B, another town C. For A to B, you have two paths or roads. From B to C, you have three roads. Okay, let's name these roads. This is A, B, this is 1, 2, 3. So if you are asked to tell in how many ways, one can travel from A to C. Tell me. In how many ways one can travel from A to C? And these all ways should be unique ways. Batao, in how many ways we can travel from A to C?
6 ways, sir.
6 way. And how did you tell that?
2 into 3.
2 into 3. And the reason behind every one of these paths, either A or B, have 3 more extensions attached with. So the paths are like A1, A2, A3, or B1, B2, B3. So all these two paths will have an attachment of 3 more paths. So the number of ways will be 2 into 3. And what if we will add a city after C, which is D, and there are 4 ways to go from C to D. Now the question is, in how many ways one can travel A to D? फटाफट बोलते चले जाओ. In how many ways one can travel A to D?
24.
24. क्यों? क्योंकि from A to C we had 6 ways, and all 6 ways will have 4 attachments. So any one of those six, like one A1, it was one of the way from A to C. It will have 4 different attachments with it, and we will get 4 different ways to reach A to D. And how do we make a figure of this 24? Like now you know how to calculate. It is 2 into 3 into 4. And if you want to have a pictorial representation, then you will be doing it like this: A, B. So A, B, and C, A and B both will have 1, 2, 3 ways. And then A1, this A1 will have again 4 ways. Similarly, A2 will also have 4 ways. So this is how we can picturize all those 24 different paths. Is everyone getting that? Can you see the 24 different paths?
Yes, sir.
Yes,
Okay,
sir.
very good. So all these questions will be solved through this theory of multiplication. So let me bring some another example. There are 3 letters A, B, C. How many words we can make with these 3 words, 3 letters, with these 3 letters without repetition? So how many words we can make? Just tell me. फटाफट बोलो, जिसको आता है वही बोलो.
So six.
How many words we can make?
Six.
6. And how did you calculate that?
We have three options for the first letter, two options for the second, and one
Yes.
option for the third.
For the last one.
Yes.
So it's a similar kind of thing, just the visualization is different. That if we have 3 places to fill, so in the first place we can either put A or B or C. Then in the second place I can either put B or C here, A or C here, A or B. And then we're left with the third letter. So the total number which I will get is 3 into 2 into 1. Okay. So what if there are 5 letters A, B, C, D, E? How many words we can make with these 5 letters without repetition? Again, you will be applying same logic. 5 into 4 into 3 into 2 into 1. Right? Is it right?
Yes, sir.
And any such expression, we will express it by factorial. It will be called 5 factorial. Here you can call it 3 factorial. So let's go for another example. I have 5 books, or I have not 5 books, I have 5 subjects: history, physics, chemistry, math, or English. I have to make a routine, a day routine of 5 lectures. In how many ways we can create a routine for these 5 subject for these 5 lectures. Dilip now. Anyone tell? 5 subjects, 5 spot of lectures. In how many way we can make a routine?
सर रेपिटेशन का कुछ है?
No, you cannot repeat 5 lectures, 5 subjects.
5 factorial.
Yes, it will be same as before. That every place needs to be filled with a subject. So for the first lecture, I will have 5 options. Then I will have 4 options. Then I will have 3 options. Then I will have 2 options. Then I will have 1 options. So now in the last 3 examples that we have made, either when it was either any of these, and I mean, like let's say there are 5 lecture slots, L1, L2, L3, L1, L2, L3, L4, L5. Whenever I put any subject in L1, let's say I'm putting history here. At this moment, the slot L1 also get exhausted. Now, for the next subject, L1 is not available. And the subject H is also exhausted. So, both variables bolo or components bolo, but there is no proper words, I think, for now. Both components got exhausted. The subject as well as the lecture spots. So the total number of arrangements that we are getting for the first slot, I will have 5 options. And then for the second, I'll have just 4 options. Then I'll have just 3 options. Then I'll have just 2 options. Then I'll have just 1 option. And 5 factorial way, in 5 factorial way, we will arrange or we can arrange the uh, subjects. Now, what if one of the variable doesn't get exhausted? What if one of the variable doesn't get exhausted? This is very important. Huh? So the situation like this, let me give you some of the situation which is frequently used for exams also. So one of the situation is when you have 4 letters, and also remember that we are taking non-identical things. On all these cases, we are taking non-identical. Like in this case, all the subjects were different. All the lecture slots were different. Okay. So currently, whatever the questions that we are dealing, they all have non-identical. So like I have 4 letter box, or a post office has 4 letter box named 1, 2, 3, 4. 1, 2, 3, 4. Why I'm calling it named 1, 2, 3, 4? Because all those 4 letter box are different. So there is a difference between all these letter box because their names are different. Okay. So why I'm emphasizing this word difference? Because I want to pitch you again that these letter boxes are non-identical. We do have a separate name and identity for all these separate or letter boxes. And you have 5 letters, again different. 5 letters for 5 friends. Why am using this 5 friends here? Because I want to establish that these 5 letters are non-identical. So even if I'll not write here this, it will be non-identical because we cannot or we never send same letter to same person, identical letter to same person. Either it will be 5 different letter to same person or 5 letter to 5 different person. So basically the things to be understood here is the letters are non-identical. So we are talking about both non-identical thing. Now, if I'm to ask that in how many ways you can post these letters to these letter boxes. अब सोचो कि क्या करना पड़ेगा. What is in your mind? How will you count that?
So 5 into 4 into 3 into 2.
So you took what? Letter as in consideration or letter box as in consideration?
So boxes.
So the what are you saying? Just tell me 5 is what? The first 5 is what?
Sir, I took boxes as consideration, ना? तो first box में 5 letters रख सकते हैं, second में 4,
ठीक है.
third में 3,
So,
फिर 2.
एक second. The problem here is you took the letter 1 in first letter box 1 and you said that 5 letters can be posted here. But you post how many letters? 5 letter can be posted here, but how many letters did you post in letter 1, letter box 1?
1.
Just 1. And then you moved to box 2. That's what you are saying, na?
Yes, sir.
Now, the problem is box 1 is not exhausted. Box 1 still can have more letters. You can post all the 5 letters into box 1 also.
That way, sir, it's for any letter box.
That is for any letter box. So the way, if you'll count in this way, so you will have to take every time, like there are 5 letter box. And if you try to count, let's say the letter, and let's name the letters also. Letters names are A, B, C, D, E. Now let's put one letter in letter box B. So again, it can be A, B, C, D, E, all. If I'll try to put 2 letter in box 1, then A, B, A, C. So there could be different combinations. Then you can put 2 letters in letter 2 or all 4 letters in letter 2, letter box 2. So finding these different combinations and counting them would be impossible for a normal human being. I mean, you can do it, but it will take an entire day to arrange in such a way so that you can count that. Okay. So the problem here that you are getting is you cannot take letter box as a reference or you cannot take the difference between the other examples, the previous example is Here, in this case, only one component is being exhausted, which is later. Later is being exhausted, but later box is not. I mean, later box can have more letters, more than one letters. So now I'll do the calculation based on letters, because whichever is exhausting, you will take that, because once it will be posted, the matter will be closed there only for that. Now let's take the letter A1. Letter A1. It can be posted in how many ways? It can be posted in how many ways? Tell me.
4.
It can, yes, it can be posted in any of these four. So I'm uh, including all the possibilities for being posted. And the moment A is posted, it gets exhausted also. So letter A can be posted in 4 different ways. Similarly, letter B can be posted again in 4 different ways, because letter box are not being exhausted. Again, the letter C will be posted in 4 different ways. Letter D will be posted in 4 different ways. Letter E will be posted in 4 different ways. Because, and this actually covers all the possibilities, because it covers, because let's say letter A is posted in B1, letter B is also posted in B1, letter C is also posted in B1, letter D. So any combination, if you can think of, it is here. And how many numbers are there? It will be, we will get it through multiplication. That's the beauty of multiplication. That's why we call it theory of multiplication. So the total number of ways which we can post the letters are 4 to the power 5. सबको समझ में आया?
Yes, sir.
बोलो, कोई ऐसा है जिसको नहीं समझ में आ रहा है? बताओ, सब लोग बताओ। इसी को और छोटा एग्जांपल लो, जैसे, because why I'm taking a smaller example, because there I can put a what map also. So let's say there are 2 letters only, A and B, and we have 3 letter box, 1, 2, and 3. So from this previous example, if someone is asking in how many ways we can post these 2 letters to this 3 letter box, so you will say that the letter A can be posted in 3 ways, and letter B can be posted in 3 ways again, and total number of ways would be 9. Okay. So now we can literally make this arrangement. So just to check that, letter A, letter B, then we can reverse it. A, A, B, B, A, A, B, B, A. Then AB in the letter 1 box. Here no letter is being posted. Then both A and B in letter box 2. And then both A and B in letter box 3. So these are all the combination in which we can actually send the letters. Now you can just count how many of them are there. So are you getting my point? So even this 4 to the 5, 4 to the power 5, which will be a very big number. So it was difficult to count in this way. This examples we can count by arranging arranging all the combinations together. And we have total 9 ways in which we can send the letters to 3 different letter box. So what we are doing, we are identifying that the two important criteria that you have to think or think and uh, observe is the two word which is very important is identical, non-identical, and second, exhausting feature of variable. So which one is exhausting? Okay. If both are getting exhausted, you will have a different way to calculate that. If only one is being exhausted, you will have different way to calculate. But you will not find the problem with the similar words every time. Like here we asked a question based on letter and letterbox. Let me frame the similar question in a different scenario. There are, just check the scenario and try to match with the previous question. There are 5 persons standing on a lift at ground floor. And there are four floors where they can get down. Okay. So where they can get down. So in how many ways those persons can get down from the lift? Are you getting my point? The question is same, but the words are different. Here, actually, you have to arrange the 5 persons in 4 different places, but place or 4 different floors, but the floor is not getting exhausted. यहाँ पे क्या है? All the floors and persons are non-identical. दिख रहा है ना सबको? And only persons are getting exhausted. बताओ सबको समझ में आ रहा है? Floors are not getting exhausted. Why? Because even all 5 persons can get down on the same floor. So in all such questions, we will start calculations with the reference of that variable which is getting exhausted. So here, persons are getting exhausted. So let name them those persons. There are 5 persons: A, B, C, D, and E. A can get down at how many floors? Or A can get down in 4 ways. Similarly, B can get down in 4 ways, and this is same for everyone. So the total number in which they can get down from the floor will be 4 to the power 5. So are you getting my point? Similar situation would be there are 7 persons person and 3 rooms where they can be accommodated. Where they can be accommodated. Accommodated. In how many ways the distribution can be done? The room distribution can be done. Tell me. Are you identifying all both the variables are non-identical and a room is not getting exhausted? One room can accommodate more than one person or all the persons. Persons are getting exhausted. That means once a person is in a particular room, he will not be in any other room at the same time. So what will be the value of this distribution? बोलो कोई तो बोलो भाई तुम लोग इतनी अच्छी
3
क्लास
to
में
the
भी
power 7.
6 to the power 7.
6 to the power 7 तीन ही पर्सन है ना नहीं सॉरी 7 पर्सन है क्या कर रहे हो तुम लोग आई डोंट नो 6 to the power 7 कौन
3 to
बोला
the power 7.
यस क्योंकि आई टेक द पर्सन first person can be put in 3 different rooms and समझ में आया नक्षत्र तुमने बोला ना 6 वाला
Yes, sir. Yes, sir.
क्यों बोला तुमने ऐसा person is getting exhausted I will count with the respect of person so first person can get into 3 different rooms second also can get into 3 different rooms similarly I can put all the 7 person in any of these 3 rooms so the total number of distribution would be 3 to the power 7 okay ठीक है यहाँ तक बोलो
Yes, sir.
Yes, sir.
वेरी गुड अच्छा अभी क्या है कि लेट्स टेक one or मतलब 2-3 more examples of 3 different situations of the same problem. First, there are 5 children's and 3 chocolates. 5-star, Cadbury and क्या होता है Kit Kat. Why I am naming these chocolates? To tell you what? Just tell me. Why I am naming these 3 chocolates?
That they're
क्या बोला तुमने सुनाई नहीं दिया
because the chocolates are non-identical.
Yes. Or in case of children, you don't have to tell that. You know, children will be different. So in how many ways I can distribute these 3 chocolates to 5 children? क्या होगा इसका आंसर बताओ? In how many ways I can distribute these 3 chocolates to 5 children? जल्दी बताओ
5:3.
5:3.
हाँ यहाँ पे हम किसको स्टार्ट करेंगे बिकॉज हु इज एग्जॉस्टिंग who is getting exhausted chocolates are getting exhausted because one child can have more than one chocolate so I'll start counting on the with the chocolates one chocolate or 5-star can be given to 5 different children Cadbury can also given to 5 different children and Kit Kat can also given to 5 different children so the total number will be 5:3 very good okay second question I told you I'll be telling you 3 questions more but there can be different situations also you need to identify that what is happening there so the other one of the question will be there are 10 MCQs questions. Now these questions will have some variety also, but the first one is same as you know the previous one. But there are 10 MCQs questions with 4 options for each. And you have to attempt all. So why I am telling you attempt all? Because you cannot leave any question. So in how many ways you can attempt the paper? तो पहले चेक करके बताओ. Are the both variable is identical or non-identical? बोलो.
Both are non-identical.
Yes, because every question is different. Or for all the questions, all the options would be different. And which is getting exhausted?
Questions.
Yes. Then question 1 can be answered in 4 ways. Question 2 can answered be 4 ways. Question 3 can answered in 4 ways. ठीक है?
4 raised to 10.
Yes. So take some another color. Like this. So 4 raised to power 10. What happens? They bring some complication in this also. What if there is no restrictions of attempt all? Then in how many ways you can do the same thing? You can attempt the paper. If there is no restrictions of attempt all, then what will happen?
10 into 4 raised to the power 10.
10 is to
4 raised to the power 10.
है कितना बोला तुमने फिर से बताओ
10 into 4 to the power 10.
नहीं now the first question can be attempted in how many ways? If there is no restriction to attempt the question, now the first question can be attempted in 5 ways. Because either you can put any of these 4 options or you can leave the question. So for each question now you have 5 ways to do that. So the total number would be 5 to the power 10. ठीक है अभी समझ में आया?
Yes, sir.
ठीक है सबको समझ में आ रहा है ना? ओके अब इसमें एक और ये लोग चेंज कर देते हैं कई बार एंड दे राइट इट इन दिस वे. नो रिस्ट्रिक्शन तो रहेगा ही बट at least attempt one question. तब कितना होगा आंसर तुम्हारा? तो हम इसमें से जो 5 to the power 10 है उसमें एक ऐसा ऑप्शन भी लाई करता है जिसमें तुमने किसी को नहीं अटेम्प्ट किया 10 के 10 उसको हटा देना है. So the final answer would be 5 to the power 10 minus 1. ये सबको समझ में आ रहा है? So this particular question has 3 different variables or 3 different variety. So you need to remember all that, not remember all, just you need to understand that what kind of variety is there. ठीक है सबको समझ में आया?
सर अटेम्प्ट
This-
वन क्वेश्चन वाला नहीं आया समझ।
नहीं आया समझ में? ऐसा देखो, मैं क्या कर रहा हूँ, इसको छोटा कर दिया जाए। लेट्स से जस्ट 3 क्वेश्चंस आर देयर, है ना? तो
ओके
फर्स्ट क्वेश्चन को तुमने, जैसे मान लो कि फर्स्ट क्वेश्चन में आइदर 5, टोटल नंबर तो इसमें भी 5 × 5 × 5 हो जाएगा, 125। इफ दिस रिस्ट्रिक्शन इज नॉट देयर कि एटलीस्ट 1 क्वेश्चन आपको करना है, देन व्हाट विल हैपन, ये रिस्ट्रिक्ट जैसे क्या बोलते हैं, इनमें से आउट ऑफ दीज 125 there will be just one way where you did not attempt any one. केवल एक ही ऐसा तरीका होगा ना जिसमें आपने कोई अटेम्प्ट नहीं किया। नॉट अटेम्प्ट एनी वन, नॉट अटेम्प्टेड एनी वन का कोई मतलब नहीं हुआ।
हम्म
तो वो क्या हो जाएगा, वो एक ही तरीका है ना, वही एक तरीका अगर हम हटा दें इसमें से 125 में से एक तरीका हटा दें, तो हमारे पास 124 ऐसे तरीके हैं जिसमें हम वो सारी चीजें काउंट कर रहे हैं, एंड एटलीस्ट वन इज बीइंग अटेम्प्टेड। यहाँ पे क्या है, ऑल आर नॉट बीइंग अटेम्प्टेड, उसका तो एक ही तरीका होगा, जस्ट रिमूव दैट।
सर
नहीं समझ में आया?
फोर नहीं आया सर, क्या हो रहा है?
अच्छा रुको, मैं क्या करता हूँ, इसको 2 ही सवाल ले लेता हूँ। लेट्स से 2 क्वेश्चंस आते हैं, ठीक है? और इसमें 4 ऑप्शंस है, ए बी सी डी, ए बी सी डी, दोनों क्वेश्चंस के लिए। आप अटेम्प्ट ऐसे कर सकते थे कि ए, इसमें भी ए कर सकते हो, ए के साथ बी कर सकते हो, ए के साथ सी कर सकते हो, ऐसे करके फिर बी के साथ सी कैसे कर सकते हो, है ना? सो
हम्म
इस सारे तरीके में तो आप कोई ना कोई अटेम्प्ट कर ही रहे हो।
हम्म
तो इसके टोटल तरीके हो गए 4 × 4,
ओके
16। अब कुछ तरीका ऐसा होगा जिसमें आप एक नहीं कर रहे हो, जैसे ए डिड नॉट अटेम्प्टेड, मतलब 1 को आपने अटेम्प्ट नहीं किया, 2 में आपने ए रखा,
हम्म
2 में आप बी रखोगे, 2 में आप सी रखोगे, 2 में आप डी रखोगे, ठीक है? 4
ओके
तरीके
सर
ये हो गए।
हम्म
और 4 तरीके वो होंगे जब आपने बी में कोई ऑप्शन नहीं दिया, बी यू डिड नॉट अटेम्प्ट, और ए में ए बी सी डी रखा, ठीक है?
ओके सर हम्म
तो हमारा टोटल तरीका कितना हुआ, 16 तो हुआ जिसमें आप दोनों अटेम्प्ट कर रहे थे,
हम्म
4 जिसमें आपने सेकंड क्वेश्चन अटेम्प्ट किया, फर्स्ट को नहीं किया,
हम्म
4 इतने तरीके हैं जिसमें आपने फर्स्ट को किया, सेकंड को नहीं किया, टोटल कितना आया, 24।
यस सर
और एक ऐसा ऑप्शन होगा जिसमें आपने दोनों को अटेम्प्ट नहीं किया।
यस सर
ये तो इकलौता तरीका होगा ना, नॉन अटेम्प्टेड का तो एक ही तरीका होगा।
हाँ जी
जैसे 1 अटेम्प्टेड के 4 तरीके हैं, मतलब एनी वन ऑफ
हम्म
देम। जैसे एक का भी दो, क्वेश्चन नंबर 1 को अटेम्प्ट कर रहे हो तब भी 4 तरीके हैं, क्वेश्चन नंबर 2 को कर रहे हो तब भी 4 तरीके, लेकिन नॉन अटेम्प्टेड का तो सिर्फ एक तरीका है,
हम्म
और ये हमारा ऐड होके 25 बनता है,
ओके
ठीक है? अब इसी को हम रिवर्स में अगर काउंट करते, तो हम क्या करते कि 1 और 2 के लिए हम निकालते हैं 5 × 5 when there is no restriction of attempt।
या
और अगर ये रिस्ट्रिक्शन है कि एटलीस्ट वन शुड बी अटेम्प्टेड, तो हमें कौन सा ऑप्शन घटाना है, यही वाला,
यस सर
which is just one way। in how many way
हम्म
will have no attempt, 1। हमारा टोटल कितना आएगा, 24, which
ओके
is
सर
same as here, ठीक है?
ओके सर
समझ में आया? तो ये
यस
हमारा जो
सर
था कि 5 × 10, it was all the possible ways where there is no restriction, and I removed just one from it because this one is the only way in which we are not attempting any question.
ओके सर
So I removed that from 5 × 10 and I got the required value. अभी प्रकृति तुम्हें समझ में आ गया रिस्ट्रिक्शन वाली बात भी?
Yes, sir.
तो ये चीज हो गई यहाँ पे clear। अब मुझे बताओ, एंड आई एम स्टिल ऑन थ्योरी ऑफ काउंटिंग, मतलब थ्योरी ऑफ मल्टीप्लीकेशन। Everything that I am doing right here, I am trying to count whatever is being asked, the number of ways or whatever, ठीक है। अब मुझे बताओ that बहुत सिंपल सा क्वेश्चन, there is a set A B C D, ठीक है। This is called set A, and the question is how many subsets of A is there? Okay, ये a different kind of questions है, but in similar nature, ठीक है। बताओ, in how many ways we can, or in how many, sorry, not in how many subsets of A is possible here or there? So if I'll count in a regular way, so first I'll take null set where there is no element. Null set is subset for all the sets, okay? Then I'll try to get all the subset with one element. So then I'll have A, then I'll have B, C, D. Then I will try to find all the subsets with two elements. So AB, then C, AD, है ना? फिर हमारे पास होगा BC, BD, और फिर होगा हमारे पास CD। Okay. Then I will count all the subsets with three element. You know what is subset, no? I think everyone have the idea of set and subsets. So I will try to find all the subsets which has three elements: ABC, BCD, ACD, ABD. Then I'll count the all the subset with four element, which will be one only: A, B, C, D. So the total numbers are 1, 4, 6, 4 and 1. कितने हो गए बताओ जरा सा? 16। ठीक है, ये समझ में आ रही तुम लोगों की बात? सेट और सबसेट समझते हो?
Yes, sir.
कोई भी ऐसा सेट जिसके एलिमेंट सेट के एलिमेंट वाले ही हो तो वो सबसेट होता है, चाहे जितना भी छोटा हो या उसके बराबर का ही। तो इवन द सेट इटसेल्फ, सेट इज आल्सो अ सबसेट फॉर इटसेल्फ, और विथ नो एलिमेंट नल सेट इज आल्सो अ सबसेट, ठीक है। सो तुमने देखा क्या कि इस तरह की काउंटिंग बहुत डिफिकल्ट हो जाएगी इफ आई टेक 5 एलिमेंट्स इन ए, ठीक है। इफ आई टेक 5 एलिमेंट्स इन, the way we have counted the subset here, it will be very difficult if I'll ask you find the subset of A if A has A, B, C, D and E और F, इतने एलिमेंट्स हो जाएंगे। तो फिर क्या करें? तो we will again now use a very different way to count, which is I will consider that a subset has, ध्यान से सुनना, subset has 4 fixed place. है ना, previous question में 4 fixed place. I am devising a new way to calculate the subset. 4 fixed place of elements, which is place 1, place 2, place 3, place 4. Now, in any subset, and this is the place for A. This is the place for A. The first place is for A. Second place is for B. Third for C. Fourth for D. So either A would be there or not. B would be there or not. C would be there or not. D would be there or not. So I can take any combination and I will get a subset. I mean, one yes, one no, then again yes, then again no. This is a subset. Yes, yes, no, no. This is again a subset. No, no, yes, no. This will again be a subset. So now counting would be easier. A will be either there or not. So there are two ways to A to be here. Similarly, B will be there or not. C be there or not. Or D will be there or not. How many subset did we find here? It is 16. Or we can call it 2 to the power 4. So if anyone wants to remember this formula, they can always remember that if there are n element in a set, the total number of subset would be 2 to the power n. But it will be very poor to remember this. Be little rich in terms of concept and always remember why it actually happened. Now, for this particular set, total number of subsets would be 2 to the power 6, which is 64. Same way that the way we have counted the subset, actually it is the same, it actually getting derived from the previous examples only, that we had 4 places. Okay, and place is getting exhausted, and we have 2 things to be put in place. One is no or one is yes, and it is not getting exhausted. So I'll be start counting with the reference of place. Place 1 can be filled in 2 ways. Place 2 can be filled in 2 ways. Place 3 can be filled in 2 ways. Place 4 can be filled in 2 ways. So you can just see that it is related with the previous thing that we have been studying. So there was one similar question, that there are 10 true and false questions. And you have to attempt all. I have to tell it. You have to attempt all because you have to put either true or false. You cannot leave any question. Attempt all. So in how many ways you can attempt all these 10 questions? So here you can find that the questions are getting exhausted, but the options are not. And non-identical, of course, these are non-identical. So every question can be answered in 2 different ways. So the total number of ways I can attempt the paper is 2 to the power 10. Okay. And one last example of similar nature that you have to remember. If I'll say there are 10 students, in how many ways we can make a group out of these 10 students? From this 10 students, see, this example is actually the same, that there is a set of 10 elements A, B, C, D, E, F, G, H, I, J. There is a set of 10 elements. Find the number of subsets because every subset will represent a group. So by getting this similarity, you can tell that, sir, total number of group would be 2 to the power 10. But this will not be a right answer because for subset, we counted no element set or null set as a subset. Here, if the question is to make a group, we cannot call a group of no elements. So there must be at least one student in that group. So we have to remove this null set from here, and the answer would then be 2 to the power 10 minus 1. So did you understand the variability here? What was different from the previous example? समझ में आया? बताओ. Did everyone get that?
Yes, sir.
कि
Yes,
हमने
sir.
-1, हाँ -1 क्यों किया? ठीक है. तो अब अच्छा, identical and other cases we can only explain once I'll introduce permutation and combination. So let me give you an example here. And all the above things that we were doing where we were using all the options. Here we will use only a limited component. Let me give you an example. That there are 5 students, A, B, C, or 6 students, or 7 students. Let me have 7 students. D, E, F, G. So there are 7 students, and you have 3 places to make them set. 3 different places, okay? So now what do you find here? Both are non-identical. And both are getting exhausted. So you will start with the same way of counting. You can take anyone as ये. Not anyone, मतलब like you can put the place, जो कम होता है ना उसको लेके काउंट करना बेटर होता है. So we have always remember, जैसे यहाँ पे 7 है और ये 3 है, तो जो कम वाला है उसको लेकर हमें काउंट करना बेटर होता है. So the first place can be put by any or first place can be first place can be filled by any of the 7 students. And the moment I'll put the first place, the place will also exhaust, and whosoever is getting seated here, that person also getting exhaust. So for the next place, I'll be left with just 6 students. And the moment I'll choose any one of them and let him sit here, the seat will also get exhaust and the person will also get exhaust. And lastly, we'll be left with 5 students. Then we can put in 5. So what happened here is that you have got actually 7 into 6 into 5 to ways to arrange these 7 students into these 3 places. So in this case, we are taking an example where both are getting exhausted, both are non-identical, but one has less value than the other. So the similar question would have been, there are 5 digits, 1, 3, 5, 7, and 9. 5 odd digits are there. In how many ways we can make a 3-digit number with them without repetition? Okay? Without repetition. If the repetition will be there, then one is not getting exhausted. Then the calculation will be done like the previous example. So let's do both. First, we'll do the without repetition. So then you will say, sir, we have 3 places to be filled by these 5 digits. 5 for the first place can be filled with 5 different digits, and then it will get exhausted, and the place will also get exhausted. Then it will 5 4 into 3. And if there is, if repetition is allowed, if repetition is allowed, allowed, then what will happen? Then you say that numbers are not getting exhausted, but the place is. So we will count with the respect of place, and then we will say that each place can be filled with 5 digits, because digits are not getting exhausted, and total number of numbers which can be made is 5 to the power 3 that we have been doing before. So this is how we did not use any permutation, name of permutation combination till now, and actually covered a very large part of your modern math. Now, in the next class, I'll be putting name to some of these things. And then I'll tell you how these things, all the name that permutation and combinations are related to these calculations only. So in next class, we will be covering the entire permutation and combination part. And in next class, the next to next class, we will be covering probability. So we'll have 3 classes. Okay. And you can watch the previously recorded lectures also before you come to the class. Okay.